These are the notes for lesson 1.4 and 1.5, solving, rewriting, and writing equations and formulas. So the first part of this lesson is solving equations. There are a lot of different types of equations and a lot of different ways to solve. As you saw in the activity that we did in class, the steps that we're taking, we want to do the reverse of that. However, in some cases, if there are variables on both sides, we first need to get all the variables onto one side before we can then solve. So number one is a special case as far as equations are concerned, because if you see, our x is in our denominator, our variable is in the denominator. So the first thing we need to do is get x out of the denominator. And the way to think of this is think of it as a proportion. So we have 3 over x equals 6 over 1. If you remember, we solve a proportion by cross multiplying. So if we cross multiply, 3 times 1 is 3. And 6 times x is 6x. Now we have x out of the denominator, now we can solve. 6 is multiplied by x, so we want to do the inverse, so we're going to divide by 6 on both sides. So x is equal to 3/6, which is the same as 1/2. So x equals 1/2. Now if we were to plug this in, 3 over 1/2, dividing by a fraction is the same as multiplying by the reciprocal. So this is the same as 3 times 2, which we know is 6. So 1/2 is the correct answer for x. If we take a look at number 2, notice that we have fractions. Most people do not like fractions, and there is a way that we can get rid of fractions to make solving a lot easier. And what we want to do is multiply the entire equation by the common denominator, or common multiple. So our common denominator, or common multiple here, we have a 3, a 4, and a 6. So the common denominator or multiple for 3, 4, and 6 is going to be 12. So we are multiplying everything by 12. So if we have 1/3 x, we're going to multiply that by 12. So 1/3 times 12, or another way of thinking about that would be 12 divided by 3. 12 divided by 3 is 4, so this is 4x. So if we multiply 1/4 times 12, again, another way of thinking about it is 12 divided by 4, which is 3. Then we want to multiply x times 12, which gives us 12x. And then we are subtracting 1/6 times 12. Again, think of that as 12 divided by 6, which is 2. Now our life is a lot easier because we don't have to deal with the fractions. So now we want to move all of our x's onto one side. So you can either subtract the 4x or the 12x. I like working with positive numbers, so I'm going to subtract 4x. Again, there are multiple ways to solve. Again, you could subtract the 12x instead. So this gives us 3 is equal to 8x minus 2. Now we have x is multiplied by 8, and then we're subtracting 2. So the opposite of subtraction is going to be addition. So we're going to add 2 to both sides. 3 plus 2 is 5, so 5 equals 8x. And then to get x by itself, we're going to divide by 8. So x equals 5/8. Again, if we plug that in, we should get a correct solution. Number 3, we have 5 times x minus 4 equals 5x plus 12. As we've seen before in our activities in class, if we have a number outside the parentheses, we know that we're going to use the distributive property. So this is 5 times x, which is 5x, minus 5 times 4, which is 20. And that equals 5x plus 12. Again, I want to get all my x's onto one side, so I'm going to subtract 5x from both sides. That gives us negative 20 equals 12. So once we have subtracted 5x from both sides, we are left with negative 20 equals 12. We know that is not a true solution, so therefore it is no solutions. So if we end up with a statement that is not true, we know that that means there are no solutions. And this just tells us that there are no values that we can plug in for x to make this equation true. If you take a look at number 4, we have 5 times 2 minus x equals 10 minus 5x. Again, notice the parentheses, so we're going to distribute first. 5 times 2 is 10. 5 times x is 5x, so 10 minus 5x equals 10 minus 5x. Now if we notice in this case, we have the same expression on both sides. Now if you continue to solve, you're going to end up with 0 equals 0, which is a true statement. Since we have a true statement, or they are equal each other, we know that that's going to give us infinite solutions. And that just tells us that no matter what value we plug in for x, any number will work. In the first 4 examples, as you will notice, we only had one variable, which is x. We may have had multiple x's in our equation, but we only had one variable. There are going to be times when equations have more than one variable, and many times it's going to be useful to rearrange the equation and solve for a different variable. So we're going to look at steps that we take in order to rearrange or rewrite equations. And many times this is the case in formulas. If we solve for a different variable, it just helps us to solve the problem with the formula. So number 1 says to solve for y. So we're trying to get y all isolated all by itself. So we want to move everything else to the other side of the equal sign. So in order to get y by itself, we first want to get rid of 7x. It is a positive 7x, so we're going to do the opposite, which is to subtract 7x. So on the left-hand side, we are left with negative 3y. On the right-hand side, we know that we cannot combine 8 and negative 7x, so we are left with 8 minus 7x. We just write them separately. Next, we need to get rid of the negative 3. We know it is multiplied by y, so we want to do the opposite operation, which is divide by negative 3. And we're going to divide everything on the right-hand side by negative 3. So we have y equals 8 minus 7x over negative 3. We can also separate this out. So we can also write this as y equals negative 8/3 plus 7/3 x. And I get this plus because we have a negative and a negative, which gives us a positive. So again, either way you can write your final answer for y equals your equation. For number 2, we're solving for x. So again, we want to get x all by itself in our equation. So we want to isolate x. So the first thing we want to do is add y to both sides. Again, we're doing the opposite since it's originally subtracted. We do the opposite, which is adding. So we have xy, which equals 10 plus y. Again, we're solving for x, so we want to get rid of the y. They're multiplied together, so we want to do the opposite or divide. So we have x equals 10 plus y over y. Now in this case, we need to split it apart because we can simplify this more. So we have x equals 10 over y plus y over y. We know that y divided by y is 1. So x equals 10 over y plus 1. And that is your final answer when you are solving for x. Now what's going to happen when we solve for y? Notice we have 2 different y's on the left-hand side of our equal sign, and they are combined with subtraction. So since we have y's in both of those terms, we can factor a y out. So if we factor out y, we are left with x minus 1 equals 10. Remember, we're solving for y, so we want to divide by x minus 1. So y equals 10 over x minus 1. And that is our final answer. So again, if you have multiple variables that you are solving for, you're going to need to factor those out before you can continue solving. Next, we're going to look at a formula. The formula for converting from Fahrenheit to Celsius is that Fahrenheit equals 9/5 Celsius plus 32. So what we can do is solve for Celsius, and that just makes it easier when we are trying to convert from Celsius to Fahrenheit. So what we want to do is solve for C. We want to get C all by itself, again, on one side of the equation. So the first thing we want to do is subtract 32 from both sides. Again, we're trying to isolate the C, so we're getting rid of everything that is with it. So this gives us F minus 32 equals 9/5 C. Now 9/5 is multiplied by C. So to get rid of a fraction, we are going to multiply by its reciprocal. So we're going to multiply this whole equation by 5/9, or the reciprocal of 9/5. So we have 5/9 on the left-hand side times F minus 32 equals C. Now you could distribute this out, but actually if you're going to be plugging into the formula, it's going to be easier to just leave it in this form, and it is completely okay to leave it in this form. So Celsius is the same as 5/9 times Fahrenheit minus 32 degrees. So again, in some cases, it is very helpful to rearrange equations and solve for different variables, depending on what the situation is that you are looking at.